it's not replacing serverless. It's kind of side by side with it.
You probably have noticed the term serverless is bubbling up again. And the question is why? Well, I think because now we actually sort of are starting to understand what it means and where we think it can go.
Hello and welcome to episode 63 of Great Things with Great Tech, the podcast highlighting companies doing great things with great technology. My name's Anthony Spiteri, and in this episode, we're talking to a software development company that's revolutionizing cloud computing with their serverless WebAssembly platform, pioneering the next wave of cloud computing by simplifying the development and deployment of serverless applications. That company is Fermyon, and I'm speaking to co-founder and CEO, Matt Butcher. Welcome to the show, Matt.
Thanks. I'm super excited to be here.
Excellent. So just before we talk about WASM and everything that is pretty new to a lot of people about to get a dose of this information, if you love great things with great tech and would like to feature in future episodes, you can click on the link on the show notes or go to GTwGT.com and register your interest. Just as a reminder, all episodes of GTwGT are available on all good podcasting platforms, the Googles, the Apples, the Spotifys, all hosted and distributed by Spotify Podcasts. And just a reminder to go to the YouTube channel at GTwGT Podcast, hit the subscribe button and the alert button, and you will get all past and future episodes. Okay, with that, let's talk about, Matt, your background and, what led you to basically start a company that is looking to change the way that I think applications basically live on the internet.
Yeah. I'm going to do the weird thing and start at the very beginning. I was a weird kid, right? I was really, even in high school, what I wanted to be when I grew up was a philosopher. So when I went into college, I went in to study philosophy, but somewhere along the way, through a variety of humorous flukes, I ended up getting a job writing code. From about 16 on, started doing some software development and viewed it as a way to pay the bills, right? And so I coded throughout. Yeah, I was actually hired to mow the lawn at a place, worked for the city of Colorado Springs, but they hired two people named Matt, and they got us confused. And so the first day I showed up for work, I showed up ready to mow the lawn, right? And they said, "Oh, well, let me show you to the place where you're going to be working." And they ushered me down to an office, introduced me to a guy named Bob. Bob says, "Hey, I'm about to leave on vacation, but here's your first assignment," and gave me a stack of books about HTML and C and Perl. This is back in 1995, right?
Wow, okay.
And then he leaves on vacation. So while he's gone, I spent this time reading about the web. I think I was using Mosaic and maybe the first version of Netscape Navigator.
Sounds about right.
Around with web.
I'm very similar vintage to you, and yeah, definitely in 1995, I was 2 years away from uni, from doing computer science and failing it miserably, but I always liked Perl. Perl was my favorite language, and I did very well in Perl, and I wrote some, not great stuff, but I wrote some of my best stuff that I did in Perl, so triggering memories all the way.
Dude, yeah, Perl got a bad rap. Perl is an amazing programming language. It is so versatile. And at the time when a lot of the stuff we were doing required big regular expressions and things like that, it was such a great language for that. But yeah, so I ended up paying my way through all the way through a PhD in philosophy, but paying my way through by doing software development. I finished that and taught for a very little while and went, I don't know, academia is sort of slow paced and, it takes a year to get a single journal article published. I think I want to be a software developer for the rest of it, and just kind of left and went back.
That's a huge pivot. That's like a serious pivot. But not so much a pivot,
still
because
paying the debt
it was side by side. Yeah. Oh, there you go. Well, there you go. Yeah. I guess it was a side by side though, right? Because you kind of, I'm guessing you were probably writing websites early days and doing all sorts of crazy stuff like that. But it was just it's just kind of cool. But really, my love is that philosophy. So yeah, it's quite interesting. Yeah. And do you still? And I think, there's a few things we'll dive into a little bit later on. But the book that you wrote on, on Kubernetes and whatnot, I think that kind of shows a bit of that background, so to speak, as well. And we can touch on it a little bit later on. But I thought that might be a good link there from where you were and where you came from.
Yeah. And I do think, I mean, as much as I make light of it, right, philosophy is a good discipline to study and has a lot of bearing on computer science. I mean, every philosopher would point out, well, computer science is built on logic, and logic is is from philosophy. But more importantly, when we write code, right, we are trying to express a very abstract idea, a very abstract system, and get it out in a language. And the language of code is far more structured than, say, English. That probably goes without saying. And there's a certain amount of rigidity in that you have to follow in order to express your ideas. So I've always found that philosophy is that coding is actually a deeply philosophical exercise. And you can tell what makes a good architect, for example, or what makes a good senior or principal level engineer. Well, it's their ability to kind of distill that abstract system into programming language that actually works and helps people get their job done. So I've always thought it was a good discipline for me.
Yeah,
and
I think that works. I think the line you draw is a fat one, and it's not long. It's not a long bow or string to bow, or bow to string, whatever way it goes.
Yeah. But that got me into sort of software development as a profession, and I kind of spent my life sort of oscillating between large companies, worked for HP, worked for Google, worked for Microsoft, and tiny companies, worked for a startup called Revolve, worked for one called Deus, worked for a small company called Palantir.net. And so I, kind of managed to get some interesting perspectives on both. Ultimately, Deus was a company that was doing very, very early Kubernetes work. And we were building a platform as a service on top of Kubernetes. Out of that came the Helm project, which is now sort of like the default package manager for Kubernetes. Microsoft was just sort of getting into the Kubernetes game at that point. Brendan Burns had just left Google and gone to Microsoft, Brendan being the creator of Kubernetes. And Microsoft acquired Deus. So that was kind of how that oscillation worked. Okay. Small company got acquired by a large company. Yeah. And there we spent, my team there, Deus Labs, spent about 5 years really sort of, first of all, honing Helm into what it is today, but also doing a whole bunch of interesting open source upstream projects that we contributed to CNCF, to Linux Foundation, and places like that.
And it's interesting, right? Because I think a lot of, and I talked about this in the pre-show with you, is that you don't see a lot of Microsoft people outwardly now in the industry, or they keep it a secret, to my point, because I think usually you're hearing about ex-Googlers, as Facebookers, all that kind of stuff. So the fact that you're a team from Microsoft through acquisition, but you still work there for a while, and now and the whole Helm thing's pretty cool as well. Like a lot of people listening will touch Helm because that's what they need if they're going to deploy stuff in Kubernetes quite easily. So it's kind of cool to be talking to you, but also to see that journey from the philosophy to HTML to Perl, to Kubernetes, to Helm, and where we are today in this land of WASM. So talk about Fermyon and how that came to be.
Yeah. And I mean, you made a really good point there about Microsoft, right? Microsoft is a great company to work for. And I think people leave their jobs for a couple of reasons. One is dissatisfaction, right? Once your satisfaction level gets low enough, then you start saying, oh, well, maybe it's time to move. But the other one is, when you start to get passionate about something that's maybe beyond the ken of what you're going to be able to do, once the passion meter really gets very, very high, then you might leave. But that's a harder bucket to fill, right? Yeah. And that was where we got. None of us was dissatisfied with life at Microsoft. I think I had the best job in all of the company, being able to do all this open source work, and all worked with lots and lots of different teams there. But when we started to hit a problem, and we actually didn't realize that it was a problem when we started to hit it. We were hitting like different facets of different frustration points. We were frustrated with not being able, with containers, when we were trying to figure out, okay, well, we want to move a container back and forth between different operating systems, different architectures. How do we rejigger the container runtime to do this? There were multiple teams at Microsoft working on that, being able to run Linux containers on Windows. Then all of a sudden, ARM is a thing again in the data center, right? And the cheapest way to operate loads. And we're like, we cannot tell developers, okay, you have to build 4 different versions of the same application. One to run on Windows Intel, one to run on Windows ARM, one to run on Linux Intel, and then, so we were trying to solve that problem. And we kind of butted our heads against the wall for a while. We were also trying to solve a problem with performance. We wanted to, so one of the most costly things you can do is in the cloud is run cloud workloads, run servers that aren't taking traffic, right? Because they're just sitting there
Just
chewing through
waiting.
your hourly, and not doing anything. So we were going, all right, well, we need to figure out a way to be able to reduce the amount of idle time. And this becomes particularly important in serverless workloads, but also in kind of your run-of-the-mill container application. And so we were trying to tackle the scale to zero problem. How, when no traffic is coming in, can you scale all the way down to zero? And then as soon as the traffic comes in, start scaling up into the thousands without the user even being aware that they're the first user to hit the machine, right?
Yeah.
And we're bumping up against containers again here, going, well, the startup speed for a container, you measure it in seconds. And a user starts to lose attention on a website at about 100 milliseconds. So there was just no way we could get this anywhere in the realm of acceptability there.
Yeah, and that's just, sorry to interrupt, but you just triggered memories again of my old days, trying to basically host applications on, IIS and LAMP stacks and all that kind of stuff. And yeah, that first person, poor person in the morning that hit the application the first time, and the application had to actually warm up at the back end, and start up. And that could be like literally some applications I remember would take minutes to warm up. And there was nothing but a spinning window basically at that point. So I think obviously that was a while ago and the technology has moved pretty significantly. But you're right. If you're spinning up multiple instances or front ends, whatever it might be, to serve these applications, you need to be very fast and very sort of efficient in that space. So I understand where the use case and the pain points are coming from there.
Yeah, and we found one technology that the developers were really genuinely excited about, but it was coming close to hitting the needs of the developer in this kind of like, okay, so here, let's put time out here. Kubernetes is a very frustrating platform for a software developer, right? Platform engineers, we like it because we can tune every little knob and dial we want until things are running really well. But for a software developer, Kubernetes can be very frustrating. You have to, the abstractions in Kubernetes have a curious way of leaking their way all the way into your code because of the assumptions of the way Kubernetes works, because of what you have to do to manage your data and manage environment variables. You just have to know about that. And when we built Helm, we knew this, and we were trying to build Helm as a tool for developers. But as we got into the kind of higher order of problem solving here, we were going, okay, so how do we make it so the developer really doesn't need to know anything at all about the underlying architecture? And we were trying to build a platform like that at Microsoft, but we started to notice developers were telling us something that was surprising to us, because we thought it was going to be a toy technology. Developers are going, hey, this serverless functions thing, Lambda functions, these kinds of things, we really like that.
Yeah.
And I'm going, oh, tell me more. Why? Well, because all I have to do is write a request and response handler. I don't have to stand up a server. I don't manage SSL certificates directly. Everything just kind of, I'm right away, like within a couple minutes of opening my VS Code or my Vim, I am writing the code that I care about. I am not doing boilerplate. And we're going, oh, that's interesting.
So this is interesting, because I come from the other side of the school, right? Like being the system architect, platform guy that used to work with the developers to keep them happy, and and it's funny. Like even when you give them something like Kubernetes, they're still not happy. You know what I mean? Like it's it's like, geez, you're giving them the key. You're basically giving them the keys to the whole platform, right? Without with almost like just, hey, have it all. We don't care what you do. It might not work at the end of the day. You might not be able to scale. You might have all these security issues, whatever. But hey, if you want to do it, you can do it. But obviously they want to get past that as well. And this whole so does this mean that the concept, because that's where DevOps comes into play in theory, right? The dev and the op coming together. So we haven't really touched on WASM specifically just yet, but is that what it kind of almost gets rid of to a certain extent? It just lets the dev be the dev?
Well, I think it gives us a better division line between what's developed, what the application developer does, right, and what the DevOps and platform engineers do. Here, I'll give you an example. I got an espresso machine, and I'm very proud of my espresso machine. So I try and work it into any example I can. but so this is the kind of espresso machine that if I want, I can take it apart. I can work on the pumps. I can very, very finely tune the internals to set the temperature. Right. That's not me. I don't care about that. That's platform engineering. Right. What I want is to make the best espresso and the best froth milk I can. And I want to have all the knobs and dials on the front that I want in order to tune that, right? I've got the lever to do the steam, and it, somewhat pressure sensitive, and another to kind of dial in the espresso, but I don't want to open the machine and do it, right? So if at the point at which the espresso machine requires me to take the back off and start tinkering with the wires and tubes, I've gone from being, the barista Matt to being, engineer Matt, or I've gone from being software developer Matt to being DevOps and platform engineering Matt, right? And so as we were building software, we were going, so one of the things that really frustrates both groups of that is when the developer has to become a platform engineer, or the platform engineer has to become the software developer. So what are good cases of that? Well, you got a 0 day, right, in production. You as the platform engineer are like, this is the highest priority possible. I drop everything to take care of this. You go and reach out to the developer who's like, dude, I got like 15 things to do today, and this is 16th on that list, right? And because you have to go back to them and say, can you rebuild the binary with a different version of libSSL, OpenSSL or something like that?
Yeah.
We're going, so like, how do we divide those so that the platform engineer doesn't have to throw things to the developer on, day 2 ops, right? And the developer doesn't have to know about the destination platform when they're in the middle of coding. And this is where, so that was really the sentiment we were hearing from serverless developers who are like, look, all I have to do is write my request response handler. And the sentiment we're hearing from the kind of frustrated Kubernetes crowd, which is like, don't let the container and Kubernetes abstractions bleed all the way into my code. And then the platform engineers, and DevOps are repeatedly saying, look, how do I keep the developers out of the production lifecycle? So that's the kind of milieu in which we're going, all right, so there's got to be a technology out there that gives us the kind of the right once run anywhere ideal, right? The
panacea, that's it.
Yeah. How do we get that so that the developer can do things the way the developer wants? And then how do we build an execution environment where the platform engineer can say, look, I can turn dials and knobs, and I can I can handle the 0 days. I can handle the way the platform certificates go. I can handle all of these things that are my job without having to throw them back over to the developer.
And that's where Fermyon comes into play, right? So founded in 2021. Just out of interest, most episodes ask about the name. So what was the origin of the name?
So this is it's physics, and as I mentioned earlier, I'm a philosopher. I have no idea what physics are. The rest of the Radu, who's my co-founder, came up with the name. He's like, look, this is the smallest particle that things are composed out of, right? The fermion is the little tiny one. And he said, this is an analogy for what we want to build. We want to be able to, we want to take the kind of microservice architecture and really realize the true potential. How can we build the smallest possible units of code and then be able to assemble those into the things of the universe that we're building as software developers?
Perfect.
Those are his words, not mine. I was
quoted him well. Very big bang theory. I love it. It's all good. Okay, so that like sometimes a company name is just a company name, but that actually is very much descriptive of what you're trying to do, and you've built that up beautifully in terms of the background and the why. So let's ask the question. So what is WASM, or what's WebAssembly?
So oftentimes the answer to the what is WebAssembly thing gets unnecessarily complicated. It's actually a very, very basic technology. All it is a binary format, right? An executable binary format. So when you build something on Windows, you're building into the XE format. When you build something on Linux, you're building into the ELF format. WebAssembly is just another one of those. What's important about it is the purpose for which WebAssembly was originally built. So, we can do the 30-second history of languages in the browser, right? What's the programming language of the browser? Well, JavaScript. But along the way, we've tried all kinds of different ways to get other languages in. The first one was Java with Java applets. Mm-hmm. And I was looking at some old stuff, and I realized that like the original vision for Java applets is that would be the language. Java would be the language, and JavaScript was just this toy language that was going to glue the Java applet to the browser. But the idea with Java was that we could take one language and we could write it and we could compile it to the Java bytecode format and we could run it anywhere. And so, Java in the browser didn't quite take off. It's actually, I don't think there are any browsers left that support the Java applet specification, but it was an idea, right? That you could compile a sophisticated programming language into a bytecode format. What happened was JavaScript, the toy language, evolved over time and became a very, very powerful programming language. It is now the #1 programming language and has been since, I think, 2013, says RedMonk. Yet still, over time, we've tried a couple different ways to say, well, can we support other languages in the browser to do other things? Most of these have been proprietary attempts like Silverlight and Flash.
I remember those. Yep. Silverlight was the Microsoft one. Flash was the Adobe.
Yeah,
I remember Silverlight was huge for a while there, wasn't it? Like, I remember doing a few things in Silverlight and some really cool stuff. Deep Zoom, I think, was one of them that was pretty cool. We could have pictures and keep on zooming in. So Microsoft were pushing it very hard. But that we're talking what, 2007, 2008 time frames type of situation.
It was a brilliant technology. I think if Microsoft, my theory is if Microsoft had embraced open source earlier, then Silverlight would have been the thing that WebAssembly now is. But WebAssembly basically came about when some developers at Mozilla said, look, there are a couple mistakes that all of these other attempts have made. One of them is trying to introduce this as a proprietary thing. Another one of these is you've always had to learn a new language and then compile that language to the bytecode format. What if, we created a bytecode format that you could compile all kinds of different languages into? And there were initial, they were like, hey, let's do C, right? Everybody, C, way too much of the universe is built on C. So let's start with C. Let's try a trendy language like Rust, which also came out of Mozilla. And then they did another brilliant thing. And they said, look, let's get Apple's Safari team, Google's Chrome team, and Microsoft at the time, Microsoft IE's team, all on the board together and say, let's do this through W3 and let's standardize it. So it's going to be open, going to be standardized. And instead of writing a new language, a new programming language, we'll write a new bytecode format. And so it took off really as a way to kind of execute all kinds of different workloads in the browser. And I think for me, my favorite example is always Figma, right? Figma wrote a whole bunch of code in C++. They compile it to WebAssembly. They run it in the browser, and they can do their vector manipulations incredibly fast in the browser because they really could optimize those low-level algorithms.
Just explain what in the browser means for people that might be going, well, okay, well, I can run a website that's in browser, but what does it mean when we're actually running like like executing something at this byte level in a browser? What's it doing? How is it interacting with the underlying hardware to execute the code versus what you'd be doing outside of that in a normal sense?
So browser side, when you're executing something browser side, you connect to a website, you download a bunch of stuff, and it's usually the HTML, the CSS, the JavaScript, and then you execute that stuff on your computer using your compute resources. And that's why, big chunky websites cause your computer to go slow, right? And that's an important detail, incidentally, with WebAssembly. So WebAssembly was designed so that you could pull the binary executable down and you could run it inside of your web browser. So you're running it locally. Now, there are a couple of key things. I just touched on one a second ago. A couple of key things you have to be able to do well if you're going to create a technology that somebody else is going to run on their computer, right? Performance is one, right? It cannot be the kind of technology where you download it and then where the user downloads it and is like, when is this website going to load, right? Nothing is more frustrating than I think I said earlier, our attention starts to dwindle at 100 milliseconds. If you're asking me to wait 3 seconds for my website to start, I'm going to be like,
too long. No, we can't do that anymore.
So speed was a big deal for WebAssembly. Security, obviously, very, very big deal. The last thing you want is to be downloading a binary that you can't even see the source code to and having it execute, and then have it like root your box and upload your family pictures to somebody else's hard drive or steal your passwords or whatever.
Mint Bitcoin or something like that,
or mine Bitcoin.
Yeah.
So you want a really strong security sandboxing layer as well. In fact, the WebAssembly security sandboxing layer is stricter than the JavaScript security sandboxing layer for reasons like you actually have to protect your JavaScript code against malicious WebAssembly binary. So it's a brilliantly constructed security platform and very much optimized towards speed from small binary sizes that you can quickly get across the network to binary format that you can execute very quickly to start it up, and then one that continues to run very efficiently in the background. So really kind of 3 performance aspects there. That's what got us interested, is that kind of runtime profile. So here we are, looking at the developers' interest in serverless functions and the kind of friction between the platform engineers and the application developers as far as who owns what and who manages what, and the rise of ARM in the data center, and of course us as Microsoft having a vested interest in running both Linux and Windows in our cloud. All of these things are kind of coming together, and we're here at in Microsoft at Deus Labs going, there's all these different problems. We can't make any headway on any of these problems, and so we're out kind of after a planning day. Our team was very distributed. We used to fly into a central location and have a planning meeting together once every 6 months or so. And this is back in like 2018. And we're going, these problems, seems like we got a bunch of problems that we just can't make any headway on. And we're just kind of chatting. It's after dinner, Canadian whiskey might have been involved. And we're just kind of going, maybe we're approaching this wrong. Right. We've been trying to build all of this stuff with the two kinds of cloud compute that we have available, virtual machines and containers. What if, and we can't bend those. We cannot bend those to our will in the way we want. What if there's like another kind of cloud compute, right? What if there's another executable format out there that would meet the needs that we're facing here? And we kind of tossed a couple of ideas around. WebAssembly was one of them. In fact, I remember my colleague Brian saying, we could look at WebAssembly. I'm like, Brian, WebAssembly is for the browser. He's like, no, hear me out. And said, what if, it's got the security sandbox model that a cloud would need. It's got the performance profile that the cloud needs, that our problem set needs. What if we just kind of plucked it out of the browser and wrote an implementation that ran on the cloud side? And that was kind of the inspiration that then 2.5 years later, we all left, a group of 10 of us left Microsoft and went and started Fermion, basically to try and build this kind of next class of cloud computing.
Yeah. So talk about a little bit, before we get into, what the Fermion Cloud is and spin and whatnot. Mm-hmm. I just want to talk about, this whole notion of what we talked, the panacea of WASM finally letting us move code between servers, clouds, and edge devices without involving, I guess, developers or even app or platform guys, right? So now that you've taken it out of the browser, you can run this on a different type of platform, and we'll talk a little bit about how that works later on in quick time. But just talk a little bit about that panacea, or that end goal of total portability for these applications.
Yeah, and you really need two pieces in order to get the kind of portability story that we envision, and the portability story that WebAssembly is shooting for, right? The first piece is you need that standard binary format, right? And a specification of exactly how to run it, so that all of these different runtimes and all these different environments can say, oh yeah, I understand this format and I know how to run it.
Because I was going to say, because just to put a little bit more emphasis on that, you can run a whole heap of languages in this particular runtime.
Yeah. But we keep pretty close watch on RedMonk's top 20 languages, and how they're progressing in WebAssembly, because what we think is, you're not gonna create a compelling technology if it supports only C and Rust, right? You need C, Rust, Swift, JavaScript, Python, Ruby, this whole litany of programming languages that people care deeply about and that have big, powerful, strong language development ecosystems. In fact, Rust isn't even in the top 20 languages, I don't think. I think it's like 22. So for WebAssembly to succeed, you need a format that all of these different languages can compile to, but that the same format can be executed on anything from, ideally an IoT device like your light bulb up to, the kind of massive 24x servers that you can get in your data center on AWS or something like that.
Yeah.
So that's ingredient number one. Ingredient number two, though, is that you need a uniform way for one of these WebAssembly things to say, these are the resources I need to be able to access. And then the runtime to be able to say, oh, I can give you those resources, right? So examples of this, I might need to read and write a file, right? My light bulb might not have a file system. My server really should have a file system, but there's all kinds of intermediate grounds where a file system may or may not be there, right? So we needed a way for WebAssembly to say, hey, these are the conditions that I need in order to run. Can the runtime supply them? And the runtime can say yes, and I'll execute you. That part is still in flight, but is almost done. And that's called the component model. Very, very boring name for a very, very exciting technology.
Okay, yeah,
where WebAssembly can say, hey, I need these components. I need a thing that looks like a database, or I need a thing that looks like a light bulb, or something like that. And then the environment can say, I can supply it. And in some cases, you can even say, hey, I need, ideally, I need a strong random number generator. But if you can't give it to me, then here, I also have this backup module that'll do sort of a weaker random number generation thing. And here's my preference, So ideally, we can build toward a fairly sophisticated environment where we can say, okay, some things can run some ways here and other ways there, but they'll be able to declare to the environment, this is what I need to run. So those two things are really the two kind of crucial bits. The first one's been done for a few years, as WebAssembly 1.0 was standardized in 2019. The binary format is now good, and we all understand it, and it's been implemented dozens and dozens of times. The second one, I think, will come along a little bit later this year, but already, a lot of us are kind of pioneering using that, Fermyon being one, but by no means the only one who's really been chatting about the component model.
Yeah. So talk about Spin, because that's obviously where you guys started to come in. I mean, that's kind of secret sauce. And then talk about the cloud. We've got about 10 minutes left. So let's talk about Spin. Let's talk about the Fermion Cloud and how that all comes together to do what you do, which is, effectively just offer a platform and the tooling to be able to let developers get their stuff up quick and have it run in a really efficient way.
Yeah. So going back to that earlier distinction, right? We want to keep developers focused on developer problems, and then platform engineers and DevOps focused on operational problems. So we really kind of set out to split those two apart in our tool chain, right? So Spin is the developer tool. You can type in like 3 commands: Spin new to scaffold out a new project, Spin build to compile it into WebAssembly, and Spin deploy to push it out to a server and basically have something running, right? That'll give you your basic hello world kind of thing, right? And then you can just start coding from there. So it's very much oriented around removing every point of friction that the developer usually experiences when creating an app and then getting it locally tested and then deployed. And it's really focused on simplifying the WebAssembly toolchain in particular. So Spin really oriented toward developers. About June of last year, we introduced Fermion Platform, which was the platform side of things, right? An open source platform that you could install into, DigitalOcean or on your local hardware or AWS or Equinix or kind of whatever you wanted, and be able to kind of play around and tune the platform to your wishes, right? So this is very much oriented toward the platform engineer DevOps team, right? Yeah. And the idea there was, hey, here's how we did it. We used Nomad, we used Console and Vault. That's the way we schedule, orchestrate, and secure things. Right. Spin is in there as the runtime, and here's a nice web UI and here's the traffic, open source traffic.
You've got HashiCorp. You've got the HashiCorp products basically for that.
Yeah. And then so that was kind of the platform engineering thing that we've built and released as open source. Then we went, okay, well, really, developers are not going to want to set that up, right? Again, respecting the division of labor that we've described. Yeah. So let's create a sort of like super high-end version of this that we can host that would allow lots and lots of different developers to run their workloads on Fermion's cloud tenancy. So we built Fermion Cloud, which is essentially the massively scalable version of Fermion platform. That's cool. And we launched that for free. We'll add paid tiers at some point. Right now it's free. And so when you type in, Spin new, Spin build, then you hit Spin deploy, it deploys it up into Fermion Cloud, which is running its own kind of mega Nomad instance and has WebAssembly execution environments on it. And you can basically go from 0 to deployed app in about 66 seconds total. So, wow, okay. That was really. I
noticed 66 seconds. It was about 66 seconds. It was a very specific number, but is it something that I think you just averaged out, or was it used for a reason?
So the original user story that we set out with, like we use a lot of user stories to drive our development, but we had kind of like the macro user story that we followed all of the year 2022. And it was, as a developer, I can go from blinking cursor to deployed application in 2 minutes. And then as we started building this, it changed to 2 minutes or less. And then as we started releasing stuff late in the year, once we had really sort of buttoned down our story, Radu is going, well, we're way under 2 minutes. So he records this video timing himself, setting up his first, Go app using Spin and deploying it, and said, hey, I can do it in 66 seconds, and here's the video to prove it. And so that became kind of the new mantra. Okay, 66.
Done. Great story, great explanation. Hey, just very quickly as well, why Nomad and not Kubernetes?
So we started with Kubernetes. Even back at Microsoft, we built a tool called Crustlet that was a WebAssembly execution environment. And what we kept bumping up against the assumptions Kubernetes made about its workloads, which was always that the shape of the workload was a container. It was going to start up, it's going to run for a long time, it was going to shut down. And here we're building these things that, while Kubernetes, doesn't start health checking till about 6 seconds into an application's lifecycle, we're writing apps that start up, run to completion, and shut down in 10 milliseconds, right? Because we're writing this kind of function as a service kind of thing where the idea is start it, run it, shut it down, because we want to scale to zero as quickly as possible. And we were just, the impedance mismatch was getting increasingly frustrating. So we spent months and months while at Microsoft writing Crustlet. When we started Fermyon, we said, all right, let's just start with a blank slate. What if we don't use Kubernetes for our orchestrator? What are the other options out there? And in about a weekend, we got Nomad, we got Spin up and running inside of Nomad, or our prototype of Spin at that point inside of Nomad, and went, oh, this is just so much easier because it's a process scheduler, not a container scheduler. So the assumptions it makes are so much simpler, but yet it has all of the features and the boons that we were finding in Kubernetes. And we just after that experience, we were just sold, we bought in hook, line, and sinker. And so this is just the way we're going to do it. It's so easy to work with, and we can get that kind of scalability story. Now, the funny thing is, since we did that, Microsoft has come back and put a lot of effort into Kubernetes and WebAssembly on Kubernetes. So you can install AKS today running Spin in your AKS cluster using their run WASM shim that actually shims all the way down into the container D layer. And they're pouring a lot of effort into this, and it's great. I mean, in hindsight, I'm going, man, I wish I had thought of doing it that way in the first place, because it's really worked out tremendously well. So what while I'm still, while Fermion is still, Nomad through and through, it does turn out that there is a Kubernetes story that's increasing in viability every day. And in fact, Docker took that same work, and when Docker announced Spin support a couple of weeks ago, that's how they did it. They used the same run WASM shim that Microsoft is using, and they run it in Docker desktop.
I was going to say, in a very quick minute, where do you think this goes? Because obviously for the longest time now we've been going Kubernetes is the future, right? Where do you see it?
I think what we're going to see is what the motion now is that we've been thinking of cluster technologies and like Kubernetes as being in a data center, right? You get your data center, you put your cluster in it. Then we started to do kind of cross data center things. But I think where we're going over the long term is we're going to see the breakdown of the idea that the cluster belongs in a data center. And we're going to start seeing the cluster as the notion that it expands way out, right? And it might include my phone and stuff in my house and stuff on a 5G tower and the data center. So we're going to see an inversion of that relationship. WebAssembly, because you can move the binaries from one to another without having to know anything about the underlying system, because it's a write once, run anywhere kind of thing, means that WebAssembly is well poised to be that technology to start to shift our thinking away from, I have my Kubernetes cluster in my data center, and into, I've got this cluster that's a dynamic organism that changes depending on where I am and what compute access I have, available to me at the moment. So that's where I think we're going, in the 3 to 5 years time frame.
It's I think it's a little bit scary from my perspective, because I think a lot of people, and I'll put it into perspective, because for a while, or for the longest time, we've been going, everyone has to understand Kubernetes and containers, right? And understand that this is where it's all going. And all of a sudden, something like this comes along and it's like, oh, okay. So now what we've been told is going to be the future might not be the future. And we have to kind of think about this new thing. And now from older man platform guy, we've got to kind of understand it. But then the other guys who are filtering down and who might still be on traditional virtualization even, holy moly, they've got something to look forward to, I suppose, in a way. And I think it changes the whole paradigm of where data gets created. How do we protect that data? Where do we store it? The concept of availability changes. It opens up this whole other paradigm, I think. So definitely think it is something to really sink our teeth into. If people listening haven't looked at WASM, get into it, because, from my quick research and understanding over the past 6 months, it's definitely on the up. And you guys are front and center of that. So in about 10 or 20 seconds, you got anything else to talk about or mention about Fermyon? I'll link a heap in the show notes, obviously, but is there any closing comments about, what you see Fermyon going into over the next few months?
No, we're looking forward to KubeCon, where we'll get to see a lot of people there, and WASM Day there, KubeCon in both EU and then in North America. So that'll be a fun chance to get to see people.
Good stuff. No worries. Well, look, thanks a lot for being on the show. It's been great. Again, we could have talked for ages. We've only got about 20 seconds left, so I'm going to wrap it up quick. But then again, you can find me, Anthony Spiteri, or go to GTwGT Podcast. If you aren't subscribed, please hit the like and subscribe button. Thanks to Matt. Thanks to Fermyon, and we will see you next time on Great Things with Great Tech.